Welcome to Mikab College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, welcome to mathematics class. I am Miss Siberu Favor, and the topic we have before us is multiplication in number bases. In our previous classes we looked at conversion and we looked at addition and subtraction, and that takes us today to the multiplication aspect of number bases. And before us we have some examples. Example 1, we are to simplify the following and express each answers in the given base. We have 3, 2, 6 base 8 to be multiplied by 1, 2 base 8. 3, 2, 6 base 8 to be multiplied by 1, 2 base 8. And the second question we have 2a base 12 to be multiplied by b3 base 12. And together we are going to look at how we can solve these problems. Solution 1, where we had 3, 2, 6 base 8 to be multiplied by 1, 2 base 8. And just like our normal base 10 multiplication, the long multiplication, we are going to be dividing 2. We are going to be multiplying 2 by 3 to 6, and also multiply 3 to 6 by 1, and then we proceed and add. But how do we do that? Because we are working in base 8. This is not base 10, so we are conscious of the base we are working with. Now, firstly, I will have, if you look at the first column, where we have 2 times 6, 2 multiplying 6 here, just like our normal long multiplication. 2 multiplied by 6, or 6 multiplying 2, will give 12 in base 10. Now, because we are not working in base 10, 6 multiplied by 2 will not give us 12 in base 8. So how do we arrive at 6 times 2 in base 8? Now we ask, because we are working in base 8, how many groups of 8 can we find in 12? How many groups of 8 can we find in 12? That's more like 8 dividing 12. So the numbers of 8 we can find in 12 is 1. We'll find one group of 8 in 12, and then we have a remainder of 4. So like we do in our normal addition and multiplication, we write the remainder and carry 1. So in this case we are going to write 4, which is the remainder, and we carry 1. That's how we have 4 here. Remember, we've carried 1. And secondly, we have 2 multiplying this 2 here. This same 2 multiplying 2. Then we have 4. Okay? Plus the one we carried earlier, remember, we carried 1 here. So that 4 plus 1 will give 5. And mind you, 5 in base 10 is still 5 in base 8, because 5 is no more than or equal to 8. So that is 5. Now also we have 2 times 3. 2 times 3 in base 8 will give 6 in base 8. Now we only convert when we have when a number or a solution is equal to 8 or more than 8. If you look at 6, 8 cannot even divide into 6. So 6 base 8 is equal to 6 base 10. Now we move to the second aspect. We will be multiplying by 1. 1 multiplying 6 here will give 6. 1 multiplying 2 here will give 2. 1 multiplying 3 will give 3. So in this case, there's no need for conversion, because all the solutions we are having by multiplying 1 are giving us results that are less than 8. So we proceed to the second aspect, just like our normal long multiplication. We'll add. So here we have 4 plus 0 here will give us 4. And 5 plus 6 Now in this case, 5 plus 6 will give 11, which is already more than 8. So we'll find what 11 is exactly in base 8. And as always, we ask, how many groups of 8 can we find in 11 here? So we can find one group of 8 and a remainder of 3. So we write the remainder 3 and carry 1. So here we have 3 and we have 1 carried. Remember that. So we have 6 plus 2 here, which is 8, plus the one we carried, that will give us 9. That will give us 9. And we ask, how many groups of 8 can we find in the 9 given? Remember, 9 is already more than 8, which is the base we are working with. So we convert it to base 8. How many groups of 8 can we find in 9? You will agree with me that we can find one group of 8 and 9 and a remainder of 1. So we write the 1, which is the remainder, and the 1 which we had, which is numbers of 8, we can find in 9, which we carried. We'll carry that and write that aside. So lastly, we have 3 here. There will be a 0 here, which is more like a placeholder. So 0 plus 2 will give 3, plus the one we carried from this very place. Plus the one we carried, we will have 4. So here, 3 to 6 base 8 multiplied by 1 2 base 8 will give 4 1 3 4 base 8. So we'll look at the second example where we have 2a base 12 to be multiplied by b3 base 12. And remember, in our previous classes we said alphabets are used to represent bases more than 10. So A here stands for 10 and B equals 11 if you've worked our previous classes. So here we'll have 3 times A, 3 multiplying A, remember A is 10, so that simply means 3 times 10, and we'll have 30. Now because we are working in base 12, 30 is already more than 12. So we ask, how many groups of 12s can we find in 30? Well, you agree with me, we'll find 2 groups of 12 in 30. That means 12 can divide into 30 2 times with the remainder of 6. So we write the remainder, which we have here, and we carry 2. Okay? And secondly, we'll have 3 times 2, and 3 times 2 will give 6. 3 times 2 will give 6, and 6 plus what we carried earlier, we carried 2. So 6 plus 2 will give 8, which we have here. 3 multiplied by 2 will give 6, plus the 2 we carried here will have 8. And because 8 is not more than 12 or equal to 12, 8 in base 10 is the same as 8 in base 12. So we have 8 recorded here. And secondly, we'll move to B multiplying A. B times A, we said A is 10 and B is 11. So it's like you're having 11 times 10. So 11 times 10 here will give 110 in base 10. This is the base 10 value of 10 times 11. But in base 12, how do we arrive at that? We ask, how many groups of 12 can we find in 110? Well, we'll find 9 groups of 12 in 110 and a remainder of 2. So like we always do, we write 2 and carry 9. We write 2, which is the remainder, and carry 9, which is the numbers of times we can find 12 in 110. So there we'll have 2 recorded. And always remember, in your long multiplication, this second space is always left vacant. So this 0 here is more like a placeholder, holding the place instead of leaving it blank. So this is the 2 we have recorded here. Then secondly, we have B times 2. B times 2, which means 2 times 11, or 11 times 2 as the case may be. So we have 22. Remember we carried 9 here earlier, so we have that 22 plus 9, and that would be equal to 31 in base 10. 31 is already more than 12. So converting it now to base 12, we ask the same question. How many groups of 12s can we find in 31? We'll find 2 groups of 12 and a remainder of 7. So we write the remainder and carry the numbers of times we can find 12 in 31, which is 2. So we have, because there is no further multiplication process here, we have that 27 recorded. So we'll proceed to addition, where we have 6 plus 0 here, we'll have 6, and 8 plus 2 will give 10. So now we'll proceed to add 6 plus 0 in base 12 will give 6. And here 8 plus 2 will give 10. And remember we said A equals 10. So instead of recording 10 here, the 10 we know, like 1, 0, we have A, letter A here. Remember it's always a capital letter. So here we have 7, like 0 plus 7 here will give 7, and 0 plus 2 here will give 2. So the result of multiplying 2A in base 12 by B3 base 12 will give 27A6 base 12. In our next class, we will look at the division in number bases. Thanks for watching, and please don't forget to subscribe to our channel.